Alright, so this lesson is on quadratic formula and the graph, and the learning goal is to use a quadratic formula to find roots and axis of symmetry of parabolas. We're going to do a little bit more than that, where we'll get to that, but yeah, that's the main thing of it. Alright, so here we have a function, alright, 2x squared plus 4x plus 1. Now we want to draw it, and immediately I want to play magic numbers, and I'm going to go 2 times 1, 2. What factors of 2 add up to 4? And I can't find any, okay? So I've got two options. I can either use the quadratic formula, or I can complete the square. Now completing the square was the last lesson, so we're going to use the quadratic formula for this. The first thing I want to show you about the quadratic formula is this part at the front. So we can split the quadratic formula into little parts. So I'm going to rewrite that. That's x equals minus b over 2a. And that gives us the axis of symmetry. Okay? So that will give us the x value that the parabola is symmetrical by. So what we need to do is always have the parabola in general form. So ax squared plus bx plus c. And that's where a, b, c all comes into this quadratic formula. They come from general form. So in this case, a is 2, b is 4. Can you see it? And then c is plus 1. Okay, so let's find the axis of symmetry. In this case, it's going to be minus 4 over 2 times 2, because a is 2, all right? Therefore, x equals minus 1. So that's where the axis of symmetry is, all right? So at minus 1, the graph should be symmetrical. So at here, the graph should have some sort of symmetry. I can rub that off for the moment. Okay, so I haven't even written it down, minus 1. Okay, so that's the first part of the formula that we can use, and it will be very powerful. Now, if I wanted to find a vertex, I would have to substitute this into the formula. So say sub x equals negative 1 into y. Now this is y, remember? So it equals 2 times minus 1 squared plus 4 times minus 1 plus 1. So it equals, that'll be 2 plus minus 4 plus 1. So 2 plus minus 4 plus 1 is negative 1. All right. So now we have our coordinate. Therefore, vertex is at the x value is negative 1 and the y value is negative 1, minus 1, minus 1. So if we look at our coordinate here, that's the x and that's the y, we can say that at minus negative 1 is the vertex. Now I know it's a smiley face because it's positive there, like the coefficient of x squared is positive, so I know it's a smiley face. So now let's calculate the roots. So this is the main use of the quadratic formula. It calculates roots. You just punch in the values here and you get it out. So let's find 4 roots. X equals, and you should memorize this, minus b plus or minus square root b squared minus 4ac over 2a, and minus b will be minus 4 plus or minus b squared is 16 because 4 times 4, minus 4 times a is 2, and c is 1. So I'm getting all these a, b, and c's from this. Remember, that's a, that's b, and that's c, written in general form. Let's put all that over 2 times a is 2, okay? Now let's start simplifying this down. I'm going to expand this a bit wider. So we've got minus 4 plus or minus, and I can put this square root, so it's going to be 16 minus 8 under the square root. I'm looking at that. So it's a square root of 8. I'm going to rub some of this square root off. And that's going to be over 4. All right, 2 times 2 is 4. So x equals, I'm going to change this third into, I'll show you. I'm going to change it using square root of 4 times square root of 2. And I know that square root of 4 is 2. Okay, so I'm going to rewrite it as minus 4 plus or minus 2 root 2 over 4. Okay, so that means, I'm going to put more working out here. That means that x equals, and I'm going to go minus 4 on 4 plus or minus 2 root 2 on 4. Now obviously we can simplify this down, okay, so we get that. But essentially what we get is x equals minus 1 plus or minus square root of 2 on 2. Okay, now that's our two solutions. Okay, now if we did, I'm going to use a bit of, I'm going to use a bit of space here to do a bit of working out. So let me go x equals one solution will be minus 1 plus root 2 on 2, and the other one will be x equals minus 1 minus root 2 on 2 from over here, if I've done everything correctly. So let's give an approximation of that number so we can see it, okay? And the first one I'm going to go minus 1, and then I'm going to put plus, and then I'll put my fraction, root 2 on 2, and I get around about 0.293 to 3 decimal places. It's a lot longer than that. And the other one, if I just change the plus to a minus, I get minus, and that was negative, I get around about minus 1.707, and then it keeps going as well. So the reason why it's good to put it in your calculator, even though we want things, nicely in like irrational form, the decimal tells us where to put it on the Cartesian plane. So negative, so I'm looking at this one, negative it's around 0.3 will be around here, and that's a negative as well. Negative 1.7, that's almost here, all right? Now I know that it crosses the y-axis at the constant, which is 1, and now I can draw my graph. Okay, I'm going to draw it in this color. So we want to do a nice curve up, and then that curve goes up. Actually, that's an awful color to see. So I'm going to change it to a deeper blue. So let's go up, and let's go up. And we can say that this is minus 1 plus root 2 on 2, and this is minus 1 minus root 2 on 2. Okay? Now, like I've done in previous times, I've done it in Desmos. So let's just have a look at it. So we've got here's our graph. The vertex which we found early on is minus 1, minus 1. And our roots are as expected as we did before. Okay? So that's really, really cool to see. All right. Let's have a look at this next graph. I forget where I am. I've got a second example. We're going to do the same thing. Now, one thing, actually, I'm going to let you do it. We can find the axis of symmetry by looking at this, okay? But what I want to look at is something that's underneath the square root. So I'm going to highlight it, this. This is called a discriminant, okay? It's b squared minus 4ac. Now we're going to work it out in this one, so that's ax squared plus bx plus c. And in this case, a is 3, b is negative 6, and c is positive 4, okay? So we're going to substitute this into this case. So let's get what b squared is. So that's minus 6 squared minus 4 times a is 3 times c is 4. So we get 36 minus, and that's 4 times 3 is 12. 12 times 4 is 48. Now, there's a problem here. We get minus 12, so our discriminant is minus 12, okay? What's the problem when we put a minus underneath a square root? Because this, remember, that this belongs underneath the square root. What happens when we put a minus? We can't do it. There's no real values, okay? And all that means is that it doesn't cross the x-axis. Now, what I'm guessing, because this is, well, it's not really a guess, I know, okay? It's got a y-intercept at 4 because of this. But because it's a positive parabola, it probably has a turning point, I don't know, I think I've done this on Desmos before, so it's around here. So it will go up and up, all right? And see how this parabola never crosses the x-axis anywhere, all right? So therefore it has no roots. So we can write something down about the parabola, okay? So this is something about discriminant. If discriminant, all right, is positive, it has 2 real roots. So I want to see this in your notes, okay? If the discriminant is negative, just like this example here, so this one was negative, it has no real roots. So what can we say? Let's write in pink. It doesn't cross the x-axis. That's essentially what it means for us. Now, there's one other occasion that we can use the discriminant. If the discriminant is 0, it has 1 root or a double root. They're both the same thing, okay? 1 root or a double root. And those ones will happen is that the turning point is on the x-axis, and it'll go up from there or it'll go down from there, okay? Notice that it only crosses at 1 point ever. Okay, what I've done is I've actually graphed this on Desmos so you can see that it doesn't cross the x-axis. So let's have a look at it. There it is, okay? Yeah, it is 1, 1, and it does cross at 4 here. And see how it never crosses the x-axis, all right? Hopefully that makes sense anyway. Anyway, that's the end of the lesson. I'll get back to my note page. Peace out.